Okay, based on questions after class, I realized that I have confused several students, probably because I think I made some mistakes on the lecture notes. So for tangent normal, first of all, you have to know the path. So I'll draw a path here. Object is on the path. There will be an origin along the path, which you'll say is s equals 0, and then if you measure the distance along the path, that's the value s. So it's the length along the path. So if you have a horse race, for example, and it's a quarter mile around, then you make one lap, you've gone a quarter mile, and so the s is a quarter mile. So that's what s is. And then you have two directions. First one is a tangent direction. Okay, and I believe your book uses variable u for a unit vector with a subscript t. We'll draw a bar over it to indicate that it's a vector. And then that is always tangent to the path. And the positive direction always points in the direction that you're moving. So anyway, then the second direction is perpendicular to ut. And that is called the normal. It always points inward of the path, and that's I believe your book uses u and an n for normal. And I put a bar over it to remind you that it's a direction. And then there's a couple of formulas that I think I messed up, but anyway, the velocity. And so I'll write a bar over it to say this is the magnitude and the direction. The velocity is equal to the speed. So I'll write it as a lowercase v. That's the magnitude or the speed that you're traveling, and you always, the velocity is always in the tangent direction. So that's the velocity equation. The acceleration equation, the vector acceleration is equal to, and this is where I think there was some confusion. It's v dot, it's the change in speed in the tangent direction, plus it's the speed squared divided by the radius of curvature times the normal. These are in the text, by the way, so and they're derived in there as well. Okay, the speed is equal to the time derivative of position along the path, and speed dot, I think one of the expressions is that your book calls it AT. It's the tangent component of acceleration. Well, yeah, of course, it's this one right here. This is the tangent component of acceleration. That's the acceleration that's in the tangent. So all they're saying is that AT is that term right there. No big deal. All right, well, so anyway, V dot is equal to S double dot. Just like there was the formula that for when we're doing x's and y's, the acceleration was equal to V dv dx. If you remember where that came from, it was the acceleration we knew was dv dt. That's acceleration. And using the chain rule, dv dt is the same as dv dx dx dt. So dx dt, right? So basically you know that this is right because the dx cancels with the dx in a sense. So that's left with dv dt. But anyway, so you take this term right here, that's equal to v. So the acceleration is equal to v, and then this right here, this term, is dv dx. And that's where this formula comes from. Well, we have the same thing in tangent normal, which looks like this. So the acceleration in the tangent, A, in the tangent direction, is equal to dv dt. And that, using the chain rule, is dv. This time it's s, not x, ds times ds dt. So this is ds dt, this term right here, ds dt. That's v, right here. ds dt is v. So the v, and then this is dv ds. Okay, so why do you use this formula? What good is this formula right here? Equals the AT. Well, what happens is if you're trying to take a derivative or anything else and you're looking for the AT component, this piece right here, when you're looking for that piece right there, you can either take the derivative with respect to time. If you know v in terms of t, you can take the derivative. It's real easy. If you don't, if you happen to know the speed in terms of position, then you want to use this formula right here. So depending on whether v is a s squared, for example, then you'd use this this term. If you said that v was equal to t cubed or something, then you would use this one. So depending on what is given. Anyway, I believe in class I had mixed up some of the s's and the v's, but these formulas are in the book. So if you have difficulty with what I'm doing here, you can read the book.